All right, everyone, we have an urgent threat briefing for you today. We're talking about React2Shell, a really critical vulnerability that's making waves across the entire React ecosystem. If you're using React or especially Next.js, you absolutely need to pay attention to this one.
So just how bad is it? Well, on the CVSS severity scale, React2Shell gets a perfect and very, very rare 10 out of 10. A score that high basically means it's the worst case scenario. It's super easy for attackers to use, and the damage they can do is at the maximum level.
And to really hammer home what a 10 out of 10 means, security experts are comparing it directly to the infamous Log4Shell vulnerability. The reason is that they share the same DNA. At its core, this is about an application trusting data from an attacker, which is a huge no-no. The server tries to piece that data back together, and in doing so, it accidentally lets the attacker run whatever code they want.
So let's get right to it. What is React2Shell? It's a critical, unauthenticated remote code execution vulnerability. We call that an RCE. And it's found in React server components. The key words to remember here are unauthenticated RCE. Let's just run through the facts, because they are pretty sobering. An attacker needs 0 credentials, no password, no login, nothing. It works against default, out-of-the-box apps. We're talking a brand new project you just spun up. And maybe the most important part, the exploit code is already out there. It's public, and bad actors are actively using it in attacks as we speak. You might also see this tracked under a separate CVE number for Next.js, but don't get confused, it's the exact same underlying problem. Okay, this brings us to the big question, the one that's probably on your mind right now. Is my application vulnerable? Let's dive into the specifics so you can go check your projects right away. All right, you're going to want to open up your package.json file or your lock file for this. The vulnerability is hiding in these specific packages: React Server DOM Parcel, Webpack, and TurboPack. Take a look at the middle column. If you're using any of those versions, you are vulnerable. You need to upgrade to one of the patched versions on the right, like yesterday. But here's the thing. It doesn't stop with just those core libraries. This problem cascades down to a whole bunch of popular tools that rely on them. The biggest name on this list, for sure, is Next.js. All versions from 15 all the way through 16.0.6 are affected. But you've also got React Router, Waku, and even Vite's RSC plugin in the mix. You've really got to check your entire toolchain.
So how in the world does an attack like this actually work? Let's peel back the layers a bit. We're going to get into the technicals, but I'll break it down for you.
The whole thing works because of a sneaky technique called server-side prototype pollution. Now, that sounds complicated, right? But think of it like this. In JavaScript, almost every object is built from a common blueprint, called a prototype. What this vulnerability lets an attacker do is scribble on that master blueprint. They can add their own malicious instructions to it. And once they've polluted that blueprint, they can trick the server into using those instructions to run any command they want. Game over. And this right here is just incredible. It shows you exactly what went wrong. The entire fix for the CVSS 10 vulnerability comes down to adding this one single check. Before, the code would just blindly grab whatever property the attacker asked for. Now, with the patch, it first stops and asks, hey, does this property actually belong to this object? That one tiny question, that one missing check, is what opened the floodgates. Now, this isn't some theoretical flaw that security researchers found in a lab. No, this is happening right now, out in the wild. And let me tell you, the attackers did not waste any time. I mean, just look at how fast this all happened. The patch goes live on December 3rd, and almost immediately, automated scanners start looking for vulnerable servers. By the very next day, a working exploit is public. By day 3, it's a full-on free-for-all. The window you had to patch before you were a target was basically non-existent. And this chart just visualizes that madness perfectly. Security researchers saw scanning for this vulnerability jump from just a few IPs to over 800 distinct addresses by December 5th. That tells you this wasn't just a few people poking around. This was a massive, coordinated effort to find and exploit servers at a huge scale. So what are these attackers actually doing once they're inside? Well, it's the whole menu of bad stuff. They're dropping crypto miners to steal your server's CPU cycles. They're running scripts designed to hunt down and steal your .env files, API keys, and all your other juicy secrets. We're also seeing them enroll servers into botnets and install backdoors so they can come back later even after you've patched. Okay, we've gone over the what, the how, and the why this is so bad. Now for the most important part of this briefing. your defense plan. These are the steps you need to take right now. We've boiled it down to a clear 4-step action plan. Number 1, and it's the most important, is patch immediately. 2, you need to apply WAF rules as a shield. 3, and this is a big one, you have to rotate all secrets. And finally, number 4, you need to hunt for any signs of compromise. Let's walk through each one. Step 1, patch immediately. This is your number 1 absolute top priority. You can run npm audit in your project, and it'll help you find the vulnerable packages. And for all you Next.js developers, the team at Vercel made it super easy. Just run npx fix-React2Shell next in your project, and it'll handle the update for you. Now, while you're getting that patch tested and deployed, move on to step 2. Get your web application firewall or WAF rules in place. All the major cloud providers, AWS, Google Cloud, you name it, they've all pushed out rules to block the known attack patterns. Think of this as a temporary barricade. It's a great layer of defense, but it is not a long-term substitute for actually patching. Step 3 is completely non-negotiable. If your app was running a vulnerable version and it was connected to the internet, you have to assume you were breached. You just have to. We know for a fact attackers are targeting secrets. That means you need to rotate everything. Your API keys, your database passwords, your session secrets, all of it. And finally, step 4, hunt for compromise. Patching locks the door, but you still need to check if somebody already got inside. Dig through your server logs. Look for any weird post requests or strange commands being executed. Security companies have published lists of known bad IP addresses, we call them indicators of compromise, that you can search for in your logs. So when we step back and look at the whole React2Shell incident, what's the big takeaway here? I think it goes a lot deeper than just this one vulnerability. At the end of the day, patching is just the first step. The incredible speed at which this was turned into a weapon shows us that just trying to prevent attacks isn't enough anymore. You also have to be ready to detect and respond. So this whole thing leaves us with one critical question you should be thinking about. Your app is patched now, but do you know who was on your server yesterday?